and in this module we will look at lenses and compare them when we are using different lenses for the same application. There are many lenses to choose from, and we will not go through all of them, but we will take 3 different ones. So the ones we will look at are the 1.5, the 2.5 and the 4-inch lens. For these samples we are using the standard settings, so this means that we are not optimizing anything for this test. So this means no alteration of speed, power, PPI or special focusing tricks, etc. It's the pure standard settings for each material we will test. Before we begin, I must emphasize that when engraving something we are looking at different things. And this can be coloring, depth, width of an engraving, phenomena that is occurring on certain materials, and not to mention the expected outcome we might have. Since subjectivity can play a role in regards to which lens to use for a particular application, we are simply going to focus on what is technically ideal to use. About the basics of a lens. So here you can see the lens, and when the laser beam will go through it, it will converge and diverge. The distance from the lens to the focal plane or focus point, i.e. the smaller spot, is called the focal length. So in this case the focal length is 2 inches, since it's a 2-inch lens. The focal plane or focus point is here, which is the smallest diameter of the laser beam in its transition between convergence and divergence. When you are focusing onto the material, you are setting the distance between the lens and the material to this point. The distance here is referred to the depth of focus, which is basically a tolerance in which the beam diameter will not change much. In other words, if you are a bit higher or lower than the focus point but within the depth of focus, you will generally not see much of a difference when engraving. So for the 2-inch lens, the depth of focus is an average of plus minus 1.5 mm, so a total range of 3 mm. For this first example, we will engrave a Trotec test graphic using the 1.5, 2.5 and the 4-inch lens on anodized aluminium. So here we can observe the results on 3 pieces, and we can see that the 1.5-inch lens is able to produce the clearest engraving in the areas where we have the smallest details. In contrast to the 4-inch lens test here, it doesn't look very good. And this happens due to the fact that the spot size is larger on the 4-inch lens than on the 1.5-inch lens. If we would boost the power using the 4-inch lens, it would look bold and not very clear in the smaller details. The reason why it looks like it does is due to the fact that we are losing energy, or its less intensity, since the spot size is larger than on the 1.5-inch lens. Since we have less intensity on the focus point, you can see that details and particularly thin lines are nearly invisible. They are there if you would look under a microscope, and it would look like a shadowing effect. Now we could reduce the speed significantly and you would see the vertical thinner lines. However, it would look bold and very undefined. The 2.5-inch lens is showing a result somewhere in the middle between the two. It looks technically speaking okay, but not as good when using the 1.5-inch lens. And the conclusion is that the smaller the beam spot size is, the smaller and detailed engraving we will get. Let's do the same test on a piece of rubber. So here we can see the results on 3 pieces of rubber, and as we can see here, the 1.5-inch lens is able to produce the clearest engraving in the areas where we have the smallest details. In contrast to the 4-inch lens test here, it doesn't look very good. It looks a bit bold and undefined. Since we are removing the background and leaving the text, it is difficult to capture the different results due to the shoulders you need around each element when doing a rubber stamp. But again, this happens due to the fact that the spot size is larger on the 4-inch lens than on the 1.5-inch lens. In contrast with the test on anodized aluminium, we are not losing thinner lines here, and the reason is that the engraving speed is so much slower when engraving rubber. The 2.5-inch lens is showing fairly good results and very good quality. However, if you would use an ink pad and stamp a paper, there is a clear distinctive difference between the 1.5 and the 2.5. And the conclusion is the same as on anodized aluminium. The smaller the beam spot size, the smaller and detailed engraving we will get. Let's cut some thick acrylic using the same lenses as the previous tests. We didn't want to give a specific thickness for this test, as it's the principle we would like to demonstrate and not what is exactly happening on, for example, 12mm acrylic. So here we can observe the 3 pieces of cut acrylic, and when using the 1.5-inch lens we can clearly see that we have an angle. And with the 2.5 the angle is still present, but it's still there. Not much, in fact it's rather okay, but if we look at the 4-inch lens we can see that there is basically no angle at all. So, what happened? Now the explanation should go along these lines. So here we have 3 lenses showing their respective focal length and the laser beam. If we now bring up the samples, you can now see, based on the shape of the laser beam, so the convergence and divergence, why this is happening. Since we have a longer depth of focus, means that we can penetrate the material further before the laser beam starts to diverge. In other words, and generally speaking, the longer the focal length, the smaller of an angle you will get when cutting thicker materials. So that was a short demonstration on how 3 different materials reacted to 3 different lenses doing the same application. If you should have any questions regarding this module, please don't hesitate to contact us.